All right, you can see the logarithmic nature of the fretboard by comparing it to the original imagery from Napier's Descriptio, his first discussion of logarithms. It has changed since then, but the original description shows the connection. The fret spacing gets narrower and narrower as you approach the other end of the string in a ratio of about 17/18. That squiggly equal sign means about or approximately. For the guitarist and keyboardist, this kind of constant geometric progression allows you to modulate throughout the key system using the same ratio. Every key is related, every fret related to every other one by that ratio. And a connection with calculus can be discovered from this comment by Dr. Ian Bruce over there at 17thCenturyMaths.com. It's a more modern translation. I have a little bit more that'll show up later. Logs, powers, and roots are all different forms of the same relation, all about arithmetic using exponents, and it reflects the common perception of things in proportion. And here are some ideas on how to relate the harmonic ratios with the logarithmic or geometric ratios. Jury is still out. I haven't had much comments on these. This is an old animation. It's not really adapted for the current YouTube, so you may have to pause it and wait for the YouTube controls to get out of the way down at the bottom there. But it gives a good description of Napier's original logarithms. A increases arithmetically, G decreases geometrically, and the distance A has traveled is the log of the distance G has to go. Got to think about that, don't you? So here is a close-up so that you can think about it. Okay, now we can stop thinking and take a look at the calculations. Okay, I don't have these books anymore, but somewhere in there somebody had used the term fiddle factor. Napier used the word whole sign. That was how he was working with it. And in my guitar analogy, that would be the open string length. When I was navigating, I used to use base 10 logs a lot. And you can never figure out what logarithm meant. I always used to see every time I saw a log floating in the water, I'd say, there goes a log floating rhythmically in the water, just to remind myself that you can't get it from base 10. You got to go back to the original. So here's some research from an old animation. It indicates numbers in proportion, and Napier chose that because the difference of two logs determines the ratio of the numbers they represent, so that an arithmetic series of logarithms corresponds to a geometric series of numbers. Well, that's the old way of thinking. All right, moving on to calculus. According to Turnbull, Newton may be said to have fused the points of view adapted by Napier and Descartes. I have a little bit more on Descartes coming up later in this vid. But into a single whole, the lines can be placed no longer parallel, but at right angles to each other. And a curve can be plotted, traced by a point which is abreast of the advancing lines. And what I just noticed is that each of these lines has both an arithmetic and geometric aspect to them. It could be measured either way. There are two different ways of writing the same number, which would be the definition of an equation, too. Now for some basics on the application of Napier's logs to the guitar. This is an inverse relationship, string length and frequency. The longer the string length, the lower the frequency, and the shorter the string length, the higher the frequency. An instrument like a slide guitar, a violin, or the voice, they are not restricted to equal tempered frequencies. And if they play alongside a guitar or a piano, they got to make some adjustments. You want to be aware. The guitar with 12-tone equal temperament looks a bit like this. I'm reading this, the 12th root of 2 to the 0 power. Anything to the 0 power would be 1, so it's 1 times the starting frequency equals the starting frequency. And then on the other side, the vibrating length, it's 1 over 1 times the starting string length, so that's the starting string length. And moving along to the first fret, I would have 2 to the 1/12. That would be 12th root of 2 to the first power, or 2 to the 1/12 is the way I've always said it. And that would be the semitone ratio of 1.059, and this is 1 over 1.059, 0.9444 approximately. Each fret raises the frequency by 1 semitone, so each fret is numbered the same as the power or the numerator of the ratio. The process continues throughout the fretboard. Every note is related by that semitone ratio, a 2 to the 1/12 raised to whatever power. And here's an earlier version. As it says here, I really have never seen anything directly connect Napier's logarithms with fret spacing on a lute or guitar, but it fits. 0.944 the base, the fret would be the power, and the full length would correspond to Napier's whole sign. And I put the calculations down here. 0.944 to the first power equals 0.944 times 650 millimeters. The original string length equals 613.6 millimeters, which is the vibrating length from the first fret. Here I am showing the 12th root of 2 as the equivalent of 0.944, but that ratio had been approximated for many years by luthiers. Using the rule of 18, that's 1/18 of the string length is continuously subtracted to give the fret spacing. And Vincenzo Galilei, that's Galileo's father, had been the first to put that into print many years earlier. Then the calculations would continue something like this. Here's the equal tempered fourth to the open string and the equal tempered fifth. And here is the octave calculation of string length. Should be kept in mind that in Napier's day, frequency ratios were not under consideration at all. That did not happen until Mersenne many years later. In general, hearing has a logarithmic aspect to it. We hear equal changes of frequency by multiplying by the same factor, such as an octave 2 to 1 or 3 to 2 the perfect fifth, etc. The idea that hearing is geometrical was first put forth by Brouncker, if I pronounce that correctly, in 1653. This idea from Lindley and Turner Smith, there's two rational ways to construct a system of tones by means of harmonic relations or else equal temperament, basically. And as I understand it, or maybe don't understand it, the equal temperament allows both systems to be used at once and that they approach each other very closely, at least in the main perfect fifth octave and perfect fourth ratios. This idea from Zarlino in 1588 might have inspired Napier. It certainly came out just a few years before Napier's first notes on logarithms, which of course went much further than this. But I would not take that idea on contingency. I would have to get a retainer check, and it would have to clear before I became convinced of the absolute truth of this idea. Here is my own translation of this, forever good or bad that translation is. Harmonious division of the octave into 12 equal parts, and down below it mentions proportional parts. It's Zarlino's use of the mesolab compass to derive equal temperament. It certainly inspired Descartes about a generation later, who made his own version of that, in which he put in the La Géométrie. And this would be my own ideas about how Descartes' compass would work in motion to describe continuous curves. And here is a bit of a history I had once written up for my own version of the mesolab. And you can see the idea goes way back to 200 BC or so. But the critical point it goes from about 1555 to about 1630. I had made up my own version from a written description of Zarlino's work, but it's really tedious. I'll put it over there on GridMath for fanatical mathophiles. And Galileo's experiments with ramps and acceleration had a similar geometric progression to it. I'll just put it here en passant. They would probably want to drop me off the Eiffel Tower when they hear that pronunciation. Kepler's explanation of the solar system as musical ratios is just a little bit too good to leave off here. And back to Napier's original logs, we're talking about mean, proportional, square root. Means and extremes is the old terminology. So for equal temperament, we would be talking about a mean proportional, and it would be log A minus log B equals log B minus log C. The only reason I might get interested in this stuff again is because coronavirus, you can't play music to a crowd. And I don't really have much else to do, so I might go back to it over there on grid math. And this is just to reemphasize the continuous proportion across the top and the frequency ratio and fret ratio of equal temperament. And this from Palmieri indicates to me the synthetic nature of the logarithmic scale. Here again, the physical basis for the mathematical ratios derived from the natural modes of the string vibration. A harmonic series is an arithmetic progression, and all the frequency ratios are whole numbers, very harmonious, sound very good. Equal temperament is a logarithmic geometric progression. The ratios of the intervals, the changes of frequency, is what is harmonious, and it gives you a better mathematical image of what's going on, a better mathematical model. It enables you to predict things a little bit better.